We're on slope binder notes. All right, what do y'all remember about slope?
Rising and running.
Rising and running. Perfect. Anything else? Slope going this way, slope going this way, like this, like this.
Horizontal.
Okay, you can have a horizontal. So that would be like this. Okay. What else? Vertical, yeah.
Diagonal.
And diagonal, absolutely. All right, look at your vocab. The slope, which is represented by a lowercase m, of a non-vertical line is the number of units the line rises or falls for each unit of horizontal change from left to right. A rate of change compares two different quantities that are changing. So y'all just said rising and running. So slope, that is represented by your rise over your run. So I want you to think back to last year. I think, Hope, you participated in this with Lawton. Did y'all have a race?
Yeah.
They had a race. Do you remember this? And were you sitting on the ground and then you had to race? So I think Lawton had to run and then rise, and Hope was able to rise and then run. Can you remember who won? Hope did, yeah. Because if you get up and start running, you're going to get there faster than if you try to run while you're sitting down, right? So you always rise before you run. Now, we also have a formula for slope. And our slope formula is y2 minus y1 over x2 minus x1. Go ahead and write that down. Let's look at our first example. It says to find the slope of the line passing through -3, 2, and 1, 5. Write those 2 points down. Since we have two ordered pairs, we can label them x1, y1, and x2, y2. We can now plug these into our slope formula. Our slope formula was y2 minus y1 over x2 minus x1. Okay, so let's plug in. What's our y2?
5.
Good. What's our y1?
2.
Awesome. x2
1.
and our y1. I'm sorry, x2. x1. Sorry. -3. Good. All right, 5 minus 2.
3.
Perfect. And then for my x's, I'll add the opposite. And what's 1 plus 3?
4.
4. Awesome. This is our slope. Our slope is 3 over 4. So that's one way you can do this, using your slope formula. Let me show you one other way you could do this, using rise over run. So I'm going to graph this on a coordinate plane. So I'll have my y-axis and my x-axis, and I'm going to plot these 2 points. -3, 1, 2, 3, 2, and 1, 5. 1, 2, 3, 4, 5. Okay, let's connect these points. Now think about last year when we had our little truck friend. Is our truck going to go up the hill or down the hill?
Gonna go up.
Up the hill. Good. So we can see, obviously, that this is a positive slope. So let's use our rise and our run. So you can choose any point to start off with. I'm going to start with -3, 2. And I'm going to rise 1, 2, 3 units. That's my rise. And then I'm going to run 1, 2, 3, 4. So 3 over 4. Is that what we got when we found the slope using our slope formula?
Yeah.
Perfect. So does it matter which way you do it?
Mm-hmm.
Does not matter. Whichever one you're more comfortable with. All right, so let's take a look at our exercises for example 1. Plot the points and find the slope of the line passing through them. You can plot them if you like, or you can just use your slope formula. It's up to you. I just want you to find the slope. Press pause. When you're ready to check your answers, press play. Number 1 was 3 over 7. Number 2 is negative 4 over 3. Number 3 is 1. One thing that we need to remember, if you're going to plot the points and then just count, you need to look at it before and just determine, okay, is this a positive slope or a negative slope? So just by looking at number 1, you can see that if we had our truck, it would be going up the hill, so that's positive. For number 2, we have our truck that's going down the hill, so you know that's going to be negative. Does that kind of make sense? Mm-hmm. Perfect. Good job. Let's take a look at example 2. We're given 2 ordered pairs, negative 4, 2, and 1, 2. All right, so let's do this both ways. Let's start off by using our slope formula. Our slope formula, we have y2 minus y1 over x2 minus x1. All right, what's 2 minus 2? What is it? 0. Good. What's negative 1 minus negative 4? You can add the opposite to help. Should just be 5. You add the opposite. All right, so 0 over 5. So if we have 0 over 5, we've got to think about what this means. Well, what is 0 divided by 5? Just 0. So we have a 0 slope. Let's look to see what this would look like if we graphed it. So go to your graph. And let's graph these 2 ordered pairs. Okay, so we have negative 4, 1, 2, 3, 4, 1, 2, and 1, 2. What kind of line is this making? Vertical, horizontal, diagonal? A horizontal line. So this is a 0 slope. Remember last year when we talked about how this helps you to make the letter Z? So when you have a horizontal line, you have the top or the bottom of your Z. And what do you think that Z stands for? 0. Perfect. So horizontal line, that's 0. If you have your 0 on top of your fraction bar, that's telling you that it's 0. We talked about last year, meaning that we would put our car on top of our line, and it would be going 0 miles per hour. Okay, any questions about that one? Before we move on to the next one, let's talk about undefined. Undefined would be when you have your 0 on the bottom, or if you were going to graph it, you would have a line that is vertical, like this. So how we can remember that is this helps us to make the letter U for undefined. And for our truck that we have, here's our truck. What's going to happen if it keeps trucking along?
It's going to hit into the wall.
Yep, he's going to fall off the cliff, and he's going to crash into a billion pieces, and he's going to be undefined. We remember that when we have our 0 on the bottom because our car is at the bottom of the cliff. It's undefined. All right, let's try a few problems. Try the exercises for example 2, 4 through 9. Press pause. When you're ready to continue, press play. Number 4 was undefined. Number 5 is undefined. Number 6 is 0. 7 is 0. 8 undefined. And 9 is 0.